Atmospheric pressure. When altimeter, you are doing numericals. Okay. Which numerical we were doing last? Okay. Become solid numbers.
We started class of numericals.
Okay, we had started classwork numerical. Which one we were doing? First one.
First one we have done.
First is completed. Okay. Okay, everybody come on page number 66. So today will be a 2-hour class. Open UT volume page 66. We will do classwork numerical. Question number 2. So what is given here? We have a cylinder in which water is filled. Okay, so what is given? Area is given as 300 centimeter square. Area of the base. Density of water is given as 1000. Okay, and till what depth it is filled? 6. So water is filled till 6 centimeters. So H is equal to 6 centimeters. Okay. Right. So area of the base is this. So you have to find the pressure. Yes. So calculate pressure and G given is 10. 10. Okay, meter per second square. Okay, so what is the pressure? Then B you have to find what? Thrust. Going thrust. How can we find it? What is the pressure formula? H rho G. And thrust is F is equal to E into A. Thrust is P into A. So first find the pressure. So basically H first to convert into meter. So how much meter it will be? And this will be how much? 300 into 10 raised to minus 4 meters. So find out. Substitute the values and find the answer. So this will be 600 Pascal. Right? Okay. What is force? Force is equal to 600 into what is the area? 300 times 4. Okay. So this will be 10 raised to minus 400. So you see that 18 Newton. This is moving. What about the other two girls? Are they expected? No idea. Right? Try the next one. बात तो नहीं हो गया बहुत क्लास से नहीं आ रहे हो एग्जाम चल रहा है उसका बात देखने का बहुत टाइम से ओके नेक्स्ट वन so next one pressure on the ground floor is given pressure on the first floor is given find the height of the pressure on the first floor pick up that this is question class let's start question number 3 so let's take pressure on the ground floor as E1 E1 is equal to how much 40,000 pascals 40,000 pascals E2 is 10,000 pascals so let's take the building like this so if this is your water tank let us say okay so this is pressure 1 here and this will be pressure 2 correct so what is the height of water column here if we take the height here this will be h1 and here the height of water column will be h2 so what you have to calculate you have to calculate find the height of the first floor hence you have to find this difference so this will be h1 minus h2. Okay imagine the water is at the base let's say the base is like this where the base is see so So now H1 minus H2 is the height of the first floor. Right? So E1 minus P2. Yeah. Is equal to what? H1 over G minus H2. Is equal to H1 minus H2. So what else? Therefore, what is H1 minus H2? Here's the. So this is the height of first floor. So just you have to subtract the row given in the question is 1000 and G is 10. So this is 1000 into 10. So this will be 30,000. Another 10,000. So this will be 3 meters. That's the answer. Okay. This is what it is. So this is ground floor. This is first floor. Next is very question for yourself. Vastika Chakravarti in our class.
Yes.
Okay, so what is given for the distance? Which is this switch?
And more.
Because these people are not able to see it. Visible, it's a screen visible to online students.
So the whiteboard, or are you sharing your
The whiteboard, is it clearly visible to all of you?
Yes, the
Yeah,
whiteboard is visible.
okay. See. Okay, now let's. So 4, can you try? It is straight formula substitution. 1.04 into 10 raised to 5 divided by 1,000. It is 1.3 into the GS 10. Okay, so these many meters, whatever answer you get will be meter. How much this will be? This is 104 into 10 raised to 3 divided by 30. So this is 8 times. So this will be 8,000 meters. Or 8 kilo. So that's what it is. So you have a hydraulic machine with a smaller piston. In the hydraulic machine. There are some forces applied here. That one. Okay, and this will experience how much load is kept here? 1250 Okay. And the smaller area is so this one is A1 and this is A2. So what is the relation? By Pascal's law, you have this relation, right? So you have to find how much force has to be applied on the smaller cylinder so that long gap. Pick up the attendance sheet. Okay. So how much force has to be applied so that the bigger cylinder is able to lift this load. F2 is also going down, but यहाँ पे जो P1 and P2 will be equal. So P1 is equal to P2 by Pascal. Or something. So this relation you get, right? So what will be F1 therefore? F1 is equal to this is what you. Has everybody understood the question? What is to be found? Great question 4. Twice. Okay. So while applying Pascal's law, you have to assume no loss due to no friction between piston and cylinder. This is the arrangement. No friction between piston and cylinder, and no hydraulic leakage. No leakage of fluid. No leakage of fluid. Okay. So then solve it.
So can we start magnetism after the effect?
Yeah, we can. Why but?
In school magnetism is being started at the reflection of light.
But what about others?
In my school, the first of portion is this first three chapters and reflection of light and magnetism.
Will go in sequence. Otherwise, if I start catering to everybody in school's demand, then it will be good. So what we can do is, while reading in school, if you come across any doubt, you can ask. I'll clear your doubt, but to teach the chapter out of sequence, that will disturb the rhythm. इसका भी तो ऐसे ही हुआ था कुछ और syllabus आ रहा था तो मैं वैसे नहीं किया somebody else also same school but different batch also this problem comes but then we follow the sequence but by end of the year will they be asking that chapter again?
Yes.
So by the end of the session we'll complete everything.
I think the magnetism chapter can be skipped.
Whatever questions, queries you have, no, you can ask me. 10-15 minutes, I'll try to answer your queries. Okay. But teaching full length chapters right now will not be possible. Okay, so everybody got the logic of this question. सबने पढ़ा question? ठीक है, तो calculate करो. अब इसमें area कितना है? So therefore F1 is equal to. What is A1? A1 is the small area. What is the small area? 5 centimeters square. So 5 centimeters square. What is the bigger area? 625 centimeters square. Into 1250 Newton. So I have expressed the data with units. Now in the ratio, no need to change the unit because anyway changed unit also will be cancelled. Okay. So यहाँ पे unit conversion करने की जरूरत है because this will get cancelled. अगर सिंगल डेटा होता सेंटीमीटर सीजीएस में बाकी सब एसआई में तो कन्वर्ट करना होगा लेकिन यहाँ पे रेशियो ठीक है
125.
हाँ
1/120.
so this is 1/125 215 ये कितना हो गया 10 that means just by applying 10 Newton you can lift 1250 Newton 1250 Newton. So what is the force multiplication? 125 times. Force multiplication is 125 times. Okay, everybody try question number 6. So similar question now. Try question 6, 7 and ask me now. Try 6, 7 yourself, everybody. Right, next question. So in this case, what you have to find? Same formula, but now you have to find F2. Okay. So since F1 by A1 is equal to F2 by A2. So therefore F2 you have to find. F2 is equal to A2 by A1 into F1. So be careful. When the force is second, then it is A1 by A2. When the force is first, A2 by A1. Full time. Okay, so better remember this formula. F1 by A1 equal to F2 by A2. Then whichever force you have to find, keep that in there. So what is given here? Diameter is given to you. So what is area? So this formula transforms into pi R2 square divided by pi R1 square into F1.
So it's square by 5 into 50 kg.
So this is equal to R2 by R1 whole square into F1. So what is given in the question is diameter. So F2. So in terms of diameter, it will be d2 by 2 into d1 by 2. So the formula finally becomes d2 by d1 square f. So I have expressed the formula in terms of the given data. Okay. So what is d2? What is r2? Half of diameter, right? d2 by 2. And what is r1? d1 by 2. ऊपर जाके क्या होगा? ठीक है? So ये अलग अलग. So what is d2? d2 is 25. 25 centimeter. This is 5 centimeter. Square of that. And what is F1? Force of 50 kgf. So this is 50 kg. Right? This is cancelled. This is 5. So 25 into 50. Here. This is answer.
So in the equation that you wrote on the top of the right side, where did the pi go? That was okay.
Such related questions you are asking me today. I'm so pleased. Where did the pi go? Okay, let's try this. Now. In question 7, the pressure is first measured using mercury. Okay, pressure is measured using mercury barometer. Now we are using a barometer which is using water. So it is the same pressure, right? So now in case of mercury, it will be, let's call
H2.
H2 rho 2 G. और इसको कर लो H1, ये खत्म हो जाएगा G. You have to find height of water. So this will be H2 rho 2 divided by. Okay, this is what we get. So what is given in the question? Given relative density of the mercury. Now, relative density is nothing but rho 2 by rho 1 itself is relative density. Okay, density of substance divided by density of water is relative density. So now you multiply. So what is H2 given to you? 0.7 meters. Into relative density is given as 13.6. Since relative density is equal to so find out whatever it is. 7, 6, 40, 4. Right. So the height of water is 9.52 meters. Okay. The 8th one you will do yourself. Why would you read yourself? Cross section. Cross section. Perfect. Cross section. Spectacular. Even cross section is when you cut any pipes, what you see is cross section. Cross section is circular radius. Every cylinder cross section is circular radius. What will be cross section of this? Right. Cross section कभी भी किसी का निकालना तो कट करो जो शेप दिखता है वो क्रॉस है कौन सा मिलेगा क्रॉस सेक्शन क्या मिलेगा सर्कल मिलेगा एलिप्स सर्कल मिलेगा कट करने के बाद एलिप्स कल कट करके देखो कट करके दोनों एक दूसरे चलो सम करो सम क्रॉस सेक्शन बहुत हो गई क्या पूछा है ओ कौन सा फॉर्मूला लगेगा which formula HROG कितने सारे हाइड्रोलिक मशीन किए हमने? सब कराया अभी अभी तो किया मेरे साथ। वो फॉर्मूला से स्टार्ट करो, फिर जो अननोन है उसको लेफ्ट में रखो, बाकी सब राइट में शिफ्ट करो। मतलब तुम लोग कर क्या रहे हो फिर? मैं जब बता रहा हूँ हाइड्रोलिक मशीन, खाली कॉपी कर रहे हो? कर लिया? आंसर दिया तेरे को। पहले क्वेश्चन पूरा पढ़ो, तो क्वेश्चन पूरा नहीं पढ़ रहा, फिर गिवन डेटा देखो, फिर कॉन्सेप्ट कौन सा लग रहा है वो देखो, फिर फॉर्मूला चूज करो, सिंप्लीफाई करो। Okay, those who have completed class work will now attempt some application type question. We'll do some 2-3 application type questions before I move to the lecture. Everyone got question 8?
Yes, sir.
Online students?
Yes, sir.
Got the answers?
Almost, sir.
So which formula do we use in question 8?
It should be.
Wherever the question is on hydraulic machines, we will use this formula. So hydraulic machine consists of 2 cylinders connected with a pipe. Okay. Out of these 2 cylinders, one will have small area of cross section, the other will have big area of cross section. So you can take A1 as small area, A2 as big area. So what is to be found here? So you have to find F2. Who got the answer? Okay, explain how you got the answer.
Sir.
Okay. So, yes. ठीक है, कहाँ से कॉपी किया? खुद से नोट किया है फॉर्मूला, लेकिन कैसे लगा है? ऐसे ही मैंने बोला इसलिए। पहले हाइड्रोलिक मशीन, जैसे ही हाइड्रोलिक मशीन बोलेंगे तो मैं ये दिमाग में आ रहा है। ठीक है, हाइड्रोलिक मशीन में 2 सिलेंडर होगा। क्रॉस सेक्शनल एरिया क्या है? इसका क्रॉस सेक्शनल एरिया A1 है, इसका A2। दोनों जगह पिस्टन है, यहाँ पे बड़ा पिस्टन है, यहाँ पे फोर्स लग रहा है छोटा वाला, और यहाँ पे कुछ लोड रहता है। ठीक है, लोड का फोर्स कितना लगेगा नीचे? ये हाइड्रोलिक मशीन है, और हाइड्रोलिक मशीन में क्या ट्रांसफर हो रहा है? इधर थ्रस्ट लगाओगे, ये एरिया, ये भी तो A1 है, तो यहाँ पे क्या लग जाएगा? P1। F1 by A1 is P1। A1 इसका एरिया, ये जो ये ना, ये पिस्टन, इसका एरिया A1 है, और इसका एरिया क्या है? वही एरिया ऑफ क्रॉस सेक्शन भी है। सिलेंडर का जो क्रॉस सेक्शनल एरिया है वही एरिया पिस्टन का भी है, A1 एरिया। तो थ्रस्ट F1 है, A इतना है, तो प्रेशर क्या लगा नीचे? P1। वही प्रेशर क्या हो रहा है? ट्रांसमिट हो रहा है फ्लूइड के थ्रू। ठीक है ना, ये जो P1 यहाँ पे लगाया वही ट्रांसमिट हो रहा है। यहाँ पे जो P2 लग रहा है पर, वो P2 विल बी इक्वल टू P1। ये है, ये हाइड्रोलिक मशीन। हर बार समझ जाते तुम हाँ हाँ करके, लेकिन बाद में न्यूमेरिकल जैसे ही आता है, बस अभी समझ आ गया सबको हाइड्रोलिक मशीन क्या है, फॉर्मूला कैसे लगाना है? हर जगह प्रेशर में F/A या हर जगह प्रेशर में HROG ऐसे नहीं लगेगा, सिचुएशन पे डिपेंड करेगा। ठीक है, कहाँ पे FYA लगेगा और कहाँ पे HOG लगेगा?
hydraulic machine का force एक side of force बताया और दूसरी साइड उसका क्रॉस सेक्शन बताया.
कहाँ पे लगेगा FYA? यहाँ पे थ्रस्ट गिवन है, यहाँ पे थ्रस्ट गिवन है. HOG कहाँ पे लगेगा? यहाँ पे फ्लूइड कॉलम है जिसमें हाइट गिवन है. समझ में आया? तो दो ही फॉर्मूले प्रेशर के और उन दोनों को कंबाइन करके क्या बनता है? हाइड्रोलिक मशीन. बस 3 फॉर्मूले. ठीक है
सर बट अगर ये चारों क्वांटिटीज दिए हो
चारों कैसे देगा?
सर चारों
किसमें चारों?
फर्स्ट क्वेश्चन एप्लीकेशन टाइप हो.
कुछ कंपैरिजन हो, मैंने पढ़ा नहीं है. पहले तुम ये देखो जो मैं बता रहा हूँ कैसे फॉर्मूला सेलेक्ट करना है सिचुएशन और गिवन क्वांटिटी पे. जो अननोन क्वांटिटी है उससे तुम फॉर्मूला इजीली गेस कर लोगे कि कौन सा क्वांटिटी नॉट गिवन है और कौन सा गिवन है. तो इनमें जो रिलेशन बनता है वही फॉर्मूला चूज कर. ठीक है, चलो एप्लीकेशन टाइप 1 पेज नंबर 67. पेज 67 एप्लीकेशन टाइप. तो एप्लीकेशन टाइप क्वेश्चन, फर्स्ट क्वेश्चन में क्या दिया है? बॉयज वेइंग 60 kg. मतलब क्या दिया है? वेट क्या होता है? वेट क्या होता है? थ्रस्ट. ठीक है, तो बॉय का जो वेट है गिवन F is equal to 60 kg. And he is wearing the shoes with heel of cross section 20 centimeters square. ठीक है, so this is the thrust due to boy and area of heel of boy. इसको A भी ले लिया. At the same time, what is the thrust of girl? Weight of girl FG कितना है? 45. And she is wearing the heel of cross sectional area
0.5 1.5
1.5 centimeters. अगर तुमको BG कंफ्यूज कर रहा है तो 1 2 भी ले सकते हो. For boy you can take 1, for girl you can take 2. Simpler. ठीक है, so you have to compare pressure exerted on ground by their heels. So you have to basically compare means you have to find the ratio of pressure due to boy and girl. So pressure due to boy divided by pressure due to girl. So what is the pressure due to boy? Pressure due to girl is FG. Okay, just take the ratio. Substitute the values. In ratio, you need not do the unit conversion, not required. Because same quantity divided by same quantity. So this is pressure due to boy divided by pressure due to girl. FG by AG. AG will go up. So 60 by 20. 45 by 1.5. So what is this? 3 into 1 by 30. So 1 is to 10. So who is exerting more pressure, the boy or the girl? Huh? So if you do this, what is the relation? P due to boy is 1 by 10 of P due to girl. What is the pressure due to boy? 1/10 of pressure due to girl. प्रेशर का गर्ल का प्रेशर इतना ज्यादा क्यों हुआ हिल पे? सरफेस एरिया बहुत कम है, ठीक है? So surface area is only 1.5, whereas thrust is 45. जबकि यहाँ पे surface area 20 है और thrust कितना है 60 इसके, ठीक है? Pressure due to boy is 1/10 of pressure due to girl. ये आंसर. Okay. Now we'll do question number 4. Application question number 4. Everybody read. Question number 4. Read question number 4. What is given in the question 4? This is the scenario. What is given here? This is a cube. This is 20 centimeters. What do you find? Pressure at the top of the cube. What is given here? Density of the water is? Yes. Density of the water given is 10 to the power 3 kg per meter cube. And rest of the things are given in the scenario. So what is the first question?
Pressure on top of.
It's all water area. So how to find pressure on top of the cube? So P is equal to, let's call this as H1. H1 rho P. Because we only require the height of the water column above the surface of the cube. Okay. So what is it? H1 is how much? 20 centimeters. So you can write it as 0.2 meter into rho is 10 raised to 3. How much is G given in the question? G you have to take as 9.8. G equal to 9.8. Okay. So this is the pressure due to, and you have to also take pressure, atmospheric pressure, P naught. How much is atmospheric pressure given? 10 raised to 5 Pascal. Okay. So you have to also add atmospheric pressure. Got it? What is the total pressure at the surface of the cube? Atmospheric pressure plus pressure due to water column. Everybody understood? What is P naught? What is P naught? What is P naught? P naught is atmospheric pressure given in the question. Read. So total pressure is pressure due to water column plus atmospheric pressure. Okay. This atmospheric pressure. Solve it. How much is this will be? Plus 32 10%. That's it. This will be 101.96. So this is the answer 101, or you can write or plus 10 raised to 5. So I've shifted the decimal by 2 places to the left. So this is a Selena textbook question only. Let's see the answer if it is correct. It must be given in the solved example. Question number. In the solved example. You have Selena? Who is Selena?
My school has Selena, but I did not.
Anybody has brought Selena today?
What is the Mario brothers?
ब्रदर में देखो है क्या ब्रदर?
Everybody brother.
ब्रदर में है क्या चेक करो. ब्रदर में हो नहीं है सर. What is the pressure at the bottom of the cube? What is the pressure at the bottom of the cube?
H2, it will be 39 centimeters. You have to take the total height of 35 centimeters.
Yes. Okay, that's the only difference. Just take height as 35. So second question में क्या हो जाएगा? So let's call this as P1. Okay. Here P1. Now P2 is equal to again P0 plus plus H2 rho. H2 यहाँ से लेना पड़ेगा अपने. Always the depth is from the free surface of water. Right in that 10 raised to 5. So it is 0.35. Go into 10 raised to 3.
So can you explain the P2 part again?
P2 is you have to find the pressure here at the bottom of the cube. What is the height from the free surface? 20 plus 15.
Yes.
So that is 35. And 35 centimeters. So we are doing 0.35 meter. This is point.
Okay, sir. Got it. Thank you.
And then just do the calculation. Okay. So what do you get now? Somebody do the calculation, tell me what is the answer. The calculation would have been easy if it was 10 instead of 9.8. Now you realize why G is taken as 10. It's very clear in the machine. Yes. Point 35. 3.43. So you will get T2 is equal to 100 plus 3.43.
103.35.
This is what you get. Then in the third part, you have to find the resultant pressure. So what is the resultant pressure? Resultant pressure is P resultant or net pressure is P2 minus P1. So this will be what? This is the resultant pressure. So how much is that? One point zero to 2.34 into 10 raised to 3 Pascal. This is the resultant pressure. So resultant thrust on the cube. What is the resultant thrust on the cube? The resultant thrust is equal to E net into area of the cube. What is the area? 0.34 times 15. Area is 15 into 0.15 into 0.15 meter square. So what it will be now? So 52.65. Okay. This is what it is. Okay, and in this question, we are ignoring buoyant force, which will be in the next chapter. तो इसके लिए हमने वो मेरे को resultant thrust में से buoyant force भी लगेगा. So where is the resultant thrust now? Upward direction or downward direction? Upward. Upward में आएगा क्योंकि P2 ज्यादा है. Yo. All right. Next. Let's take one more question. So, can I go to the yes. Question 5. Let's do question 5. Everybody understood this question? Basically, we have to actually take into account atmospheric pressure also here to calculate the total pressure. Next. Question 5. Can I erase this part? So everybody read question 5 twice. Tell me how will we solve it. will you do it? So, have you understood the question? You have a lake. Let us say this is a lake. Some lake here. Some lake. So there is a bubble. Let's say it is at the bottom. Its volume is V. When it reaches the surface, the volume is doubled. And that's why the volume is doubled. When it reaches the surface, volume is doubled. So volume becomes how much? 2. Let's say the pressure at the bottom is E1. And this is V2 is equal to 2 times E1. This is what has happened. And what is the pressure here? P2. And this will be equal to atmospheric pressure. At the top, what is the pressure? Atmospheric pressure. So what is Boyle's law? P is inversely proportional to V. P is inversely proportional to V. So since P is inversely proportional to V by Boyle's law. So what the relation will be? Therefore, P1 upon P2 will be equal to P2 upon P1. This is what we'll get. By Boyle's law, we'll get this relation by taking the ratio. So we have to find the depth. Depth of the lake is, let us say, H2 or H1. Okay. So therefore, H1 O P upon P2. And what is P2? 2 times V1 upon V1. So what you have to find out in this question? In this question, you have to find the depth of the lake. Now, these are application-based question, okay? So here you have to apply the knowledge of Boyle's law. So what is H1? Therefore, H1 is equal to. So V1 gets cancelled. 2 times 2 divided by 4 n. This will be the depth of the lake.
So who is Boyle?
Boyle's law.
Boyle. Who is Boyle?
Scientist in chemistry, have you not studied Boyle's law? So you'll study whenever there is a relation between pressure and volume. Okay, so at a constant temperature, pressure is inversely proportional to volume. Pressure of fluid. What is pressure? Pressure of fluid. So if you try to squeeze more and more fluid in a smaller volume, its pressure will rise. Okay, that's what it is. Like when the gas is inside the cylinder, it is at high pressure. When it comes out in the room, the pressure reduces. Okay, that's what it is. So now substitute and get it. What is P2? P2 is same as atmospheric pressure. Okay. So P2 is where P2 is same as it is. These things are given. Okay. So what is the depth now? So this is 2 P2. How much is the atmospheric pressure given in the question? So P2 you can write. Okay, this is 2 into P2 is given in terms of density of mercury. For is the density of water given? This is density of water. The atmospheric pressure is given in terms of 76 centimeter of Hg. Now you substitute everything. So this is a really tough question. So many things they have done here. P2 is not given directly. P2 को कैसे दिया है? In terms of height of mercury. So height of mercury क्या है? Two. This is given as 76 centimeter. So write 0.76 into density of mercury is 13.6. It is given gram per centimeter. Okay. And G will get cancelled, so that's okay. So all data you can keep it in CGS, no issues. 76 centimeters into, because you have density 13.6 gram per centimeter cube. Just express the units also. This is water density is 1 gram per centimeter. Okay. So you can cancel this also. So what do you get? 76 152 into 13.6 centimeter. This will be the height you get. So find out how much is this. So this is the depth of the lake. The deepest point is 20 meters deep. Next question, I'm just trying to understand. It's not pretty straight. Yes, sir. Not very straight question. Read the next question. Question 5 is clear to everyone? The next is easy. I was thinking of 7. 6 terms of those. Everybody try question 6 yourself. 6 हो गया. Online students, question 6. How do we approach this? What length of water column is equivalent to 0.76 meter of mercury column? State the assumption made in your calculation. मर्करी की बजाय वाटर ले रहा है तो कितना लेंथ लगेगा? सेम हाइट में मिल जाएगा, सेम प्रेशर. So pressure due to water column must be equal to pressure due to mercury. Equate करो P1 equal to P2. H-rho-g लगाओ. क्या होगा?
Mercury का density किस सकते हैं?
13.6 times होता है water की density.
हाँ. तो H1 is equal to H2 multiplied by 13.6.
जी तो कैंसिल हो गया. रो2 by रो1 कितना आता है? 13.6 आएगा. H1 कितना है? H1 है तुम्हारा 0.76. ये आएगा 13.6 into 10 to the power 3 divided by 10 to the power 3. वाटर का होता है 1000 डेंसिटी. और 13.6 times 1000. तो ये कितना आ गया? तो 13.6 into 0.76 कितना आ गया? ठीक है. ऐसे और क्वेश्चंस तुम ट्राई कर सकते हो. अभी हम करेंगे. ये कितना आ गया? क्वेश्चन
10.336.
10.336 कितना मीटर होगा? ठीक है ना. Okay, turn the page. We'll do some diagrammatical question. Look at question 12. What fact about liquid pressure does the following diagram in the figure illustrate?
Sorry, exam.
What fact does it illustrate?
And I said, if we make 2 holes in a bottle, this picture, the hole is the bottom. The hole is the core. The water is the
वो तो दिख रहा है पिक्चर में. तो फैक्ट क्या है? फैक्ट चलो ठीक.
because the pressure of water is greater at the bottom of the water.
Yes. तो fact क्या बना?
Pressure increases with time.
Yes. This picture illustrates
Pressure is directly proportional to depth.
pressure increases with depth of the fluid column. ये fact है. देखो. Question 12 में. ठीक है? वैसे ही on page number, so this is a question on page 68. This question we are talking about. Page 68. Okay. So what is the fact? Pressure increases with depth. What about this question? Everybody look at this question. Question number 2, page 69. Who will answer the first part?
Yes.
Yeah?
Can I try?
Yeah, try.
In the first figure, in the first question, there are two figures. One figure represents seawater and second figure represents river water.
Good.
As the density of seawater is more compared to the river water, the pressure in seawater would be more
Correct.
than the pressure in the river water.
Exactly. So same depth. P1 and P2 are the pressure at same depth. So in the sea water, the pressure will be higher. Although it is 3 meters below the free surface. Okay. So why it will be higher? Because the water density, sea water density is higher than fresh water. This is correct. Second and third,
Pressure is
different people have to try. Who has not answered, try. P1 is equal to P2 in the second case. Why? They are at the same level. Pressure is same at the same level. So basically, in this question, we are verifying the laws of pressure. Okay, third and final diagram. Who would try? Yes. The same question as 12 on the previous page. These are questions related to laws of pressure. तो ऐसे आता है, ठीक है? तो हमने बहुत सारा टाइप का क्वेश्चन किया. अभी बॉयल्स लॉ का भी एक आ गया. वॉल्यूम जब भी डबल हो जाता है तो P is inversely proportional to V. ये सब एप्लीकेशंस ऑफ प्रेशर है ना, उसमें कवर किया. All right, so I think we are good to go to the next chapter now. Okay, we'll start. I'll introduce. We have half an hour, so I'll introduce Upthrust in fluids and Archimedes principle. So that is the next chapter. How did you like this chapter?
it is very
Okay, let us move on to next chapter, which is Upthrust. So it is Upthrust in fluids. So rest of the questions are homework for you. Okay, classwork we have completed. The remaining questions will try. So in the last chapter, we studied about thrust. In this chapter, we are going to learn about upthrust. Let us see what is it. What was the example of thrust? Weight. Weight was the example of thrust. So what is weight? It is a downward force. So what should be upward what should be upthrust? It should be upward force. Is the tendency, it is the upward force. Exerted by the fluid. It is the upward force exerted by the fluid whenever any object is submerged in the fluid. Any object submerged in. ठीक है, what is upthrust? लिक्विड में या फ्लूइड में कोई भी बॉडी को तुम डुबाओगे, लिक्विड क्या करती है उसके ऊपर अपथ्रस्ट लगता है। इसीलिए कोई भी बॉडी क्या करता है, फ्लोट करता है। फ्लोट क्यों करता है? बिकॉज ऑफ अपथ्रस्ट। ठीक है, दिस प्रॉपर्टी ऑफ लिक्विड this property of fluid to exert upthrust. It is called buoyancy. So the property of the liquid or fluid to exert upthrust on any body submerged in it is called buoyancy. And the upthrust itself is called buoyant force. You know? Hence, the upthrust is also called buoyant force. M. Upthrust is also called buoyant force M. ठीक है, समझेगा? Generally, you will observe three things whenever a body is submerged inside liquid. Some bodies will, when you leave them in water, they may float like this, like a ship. Some part is above the surface of water, some is below it. It may also happen that the object is fully submerged, but still floating. Okay, some swimmers can have their, like fishes and all, they can float on the surface. Okay, like they are floating above only, but fully hidden inside the water. That can also happen. In the third case, you may have body which is sunk. Okay, so body may be sunk, maybe. Okay, it will sink. Like the third case is the example of the body which is already sink. Okay, sink or sunk. What will you say?
Sunk.
Sunk. Okay, the body is sunk. So these are the three cases possible. Is there anything else? You may have body suspended in between. Okay, so suspended in between is the same case like this. Same case. Okay. Now, the first two cases are rotation. Case one is body floating with partially submerged. Case two is body floating with fully submerged. Body floating with fully submerged. And what is the third case? Completely submerged. Okay. Now you should ask a question. What is causing the body to float there?
Because it is full of air.
Full of air.
It's density. Low density. Low density. More content of the
Lower density than the density of
water.
water. So we'll prove that. Okay. But tell me in terms of the forces acting on the body. What are the forces acting on the body?
Upthrust buoyant force.
Thrust and buoyant force are the same thing. One is weight, the gravity. So where is the gravity acts?
On the midpoint.
Center of gravity. So its weight is downward. How much is the weight?
No.
F equal to mg. Weight is always gravitational force, downward, mg. And where is the upthrust acting on it? So gravity acts as center of gravity. मतलब कि gravitational force acts on center of gravity, whereas buoyant force acts on center of buoyancy. That is B. Buoyant force is acting here. Right. So what is G? Center of gravity. Weight of the body acts at center of gravity, CG. So what is G? And it is the geometric center of the body. Like if it is a cube, take the intersection of diagonals. Wherever the diagonals intersect, that is the center of gravity. Whereas what is B? Center of buoyancy. So your buoyant force act at the center of buoyancy. Okay. So what is center of buoyancy? Can you see the submerged portion of water? What is the volume which is submerged in water? This part, this part, underwater. Now B is the center of gravity of the volume which is inside water. You understood? B is the center of gravity of the volume of the body which is inside water. Okay, so obviously B will be below D. Understood? Is that clear? So what is the significance of center of buoyancy? Buoyant force acts at center of buoyancy. Acts at weight of the body acts at center of gravity G. G is called center of gravity. Is it clear now? So where is center of gravity and center of buoyancy in the second case? And for the first case, obviously the buoyant force must be greater than the weight. That is why body is floating.
So can the center of buoyancy and center of gravity be same?
Yes, that's what it is here. So G and B are the same point here. In this case, FB is greater than F. In the first case, buoyant force is greater than the weight. That is why the body is floating. Right? Now here, yes. Here mg is below and this is upward. In this case, buoyant force is equal to weight of the body. Buoyant force is equal to weight of the body. What about the third case?
The gravitational force.
Yes. In this case, F and buoyant force is small. Small and large force you will show with the length of the vector. Here FB is bigger than F. Okay, see B is this much, whereas F is only small. G से start होता है, ठीक है? तो ऐसे length से दिखाओ, यहाँ पे दोनों का length equal है. यहाँ पे क्या होगा? Weight you have to show FB as smaller than buoyant force. Okay. So are these three same bodies or different bodies?
Same bodies.
Same bodies में कैसे होगा?
Different bodies.
Has to be different bodies.
The
Liquid is same.
this second is you said that buoyant force and the gravitational force are both equal.
Equal. इसीलिए तो float हो रहा है.
Yes, but it is difference in the middle of the container. The object is situated in the middle of the container. Then
उसमें भी same. Suspended. यहाँ से लेके यहाँ पे या कहीं पे भी हो, तो ये वाला buoyant force is greater than this buoyant force. Sorry, this one is greater than this buoyant force. क्योंकि इसमें क्या होगा, अगर इसको पूरा डुबाना है तो मेरे को और फोर्स लगाना पड़ेगा. ये केस बनाने के लिए I have to apply some additional force. ठीक है, और जैसे मैं छोड़ूंगा फिर से ऊपर आए, मतलब buoyant force इस केस में ज्यादा लग रहा है. समझ आए? तो यहाँ पे क्या हो जाएगा थर्ड केस में?
gravitational force rather than
Yes, FB is, ये वाले केस में FB is less than gravitational force. तीनों केस समझ आ गया? तो दो केस फ्लोटेशन का है और एक वाले में क्या होगा, डूब जाएगा. तो कब buoyant force, कितना buoyant force लगता है वो कौन बताता है? वेट तो हमको बॉडी का मालूम है. अगर मास पता है बॉडी का तो वेट कैसे निकलेगा? मास इनटू ग्रेविटी. तो buoyant force कौन बताता है कि बॉडी में कितना लग रहा है?
second object को क्या तरीके
कर सकते हैं यहाँ नहीं, विदाउट नहीं, फिर तो वो वहीं पे इक्वल हो गया ना. इक्वल हो गया तो वहीं पे रहेगा, वो सरफेस पे रहेगा. दो ही केस होता है फ्लोटेशन का, या तो पार्टली सबमर्ज या ऊपर है. बीच में मान लो तुमने इसको फोर्स लगा के कर दिया तो वो वहीं लटका रहेगा. अगर तुमने उसको फोर्स लगा के किया बीच में तो जहां तक लेके जाओगे वो वहीं रहेगा, क्योंकि नेट फोर्स जीरो है, नहीं आएगा. मान लो कुछ है उस पर, कुछ चिड़िया बैठी है कुछ हो, तो थोड़ा और नीचे चला जाए. समझ आ रहा है? क्या एग्जाम्पल मेरे को तो समझ नहीं आ रहा है. तो पहले ही ऐसा एग्जाम्पल समझ, तुम कहीं ऐसा फिश टैंक में देख सकते हो कुछ डाल के कि सस्पेंडेड है क्या नहीं. अलग अलग टाइप के ऑब्जेक्ट डाल के देखो, वो ऑब्जेक्ट की प्रॉपर्टी पे है.
सर तो सेकंड केस में लाइक अगर कंटेनर पे टॉप पर टच नहीं हो रहा, बॉटम पर टच नहीं हो रहा, तो buoyant force और
वही तो है ना, क्या है, ये तो है buoyant फोर्स और ग्रेविटेशनल फोर्स इक्वल है। ग्रेविटेशनल फोर्स ही वेट है, वही थ्रस्ट है, और buoyant फोर्स क्या है, अपथ्रस्ट। तो कंफ्यूज नहीं होना है, खाली डायरेक्शन ऊपर नीचे, वेट का डायरेक्शन नीचे है तो वो भी थ्रस्ट, और buoyant फोर्स का क्या है, अपथ्रस्ट। अपथ्रस्ट
और इसमें भी मास के लिए अंदाजा पड़ता है।
वेट में तो मास आएगा ही ना, mg। ठीक है, अब हमें अपथ्रस्ट मैथमेटिकली कौन बताता है, आर्किमिडीज प्रिंसिपल। ठीक है, तो अब देखते हैं व्हाट इज आर्किमिडीज प्रिंसिपल। ठीक है, ये सब समझ आ गया, सेंटर ऑफ ग्रेविटी क्या होता है, सेंटर ऑफ बॉयंसी क्या होता है। तो सेंटर ऑफ ग्रेविटी और सेंटर ऑफ बॉयंसी में क्या रिलेशन है, सेंटर ऑफ ग्रेविटी और सेंटर ऑफ बॉयंसी में क्या रिलेशन है, देख के बताओ। दो ही रिलेशन बन रहा है यहाँ पे, पार्टली सबमर्ज्ड में कुछ है और फुल्ली सबमर्ज्ड में कुछ है, क्या है देख के बताओ।
Partly submerged में gravity is less than point force, but fully submerged में
तो फोर्स मैं पॉइंट पूछ रहा हूँ, सेंटर ऑफ ग्रेविटी और सेंटर ऑफ बॉयंसी में क्या रिलेशन। सेंटर ऑफ ग्रेविटी हमेशा सेंटर में होता है, सेंटर ऑफ ग्रेविटी बॉडी के सेंटर में, हर जगह पे, सी कभी चेंज नहीं हो रहा। सेंटर ऑफ बॉयंसी शिफ्ट होता है। ठीक है, सेंटर ऑफ बॉयंसी कहाँ पे शिफ्ट होता है, यहाँ पे सेंटर ऑफ बॉयंसी, सेंटर ऑफ ग्रेविटी फुल्ली सबमर्ज्ड में वो दोनों सेम ही है। नहीं नहीं, सेंटर ऑफ बॉयंसी सेंटर ऑफ ग्रेविटी से नीचे शिफ्ट हुआ ना यार इस केस में।
Yes.
So for a partly submerged situation, center of buoyancy is below the center of gravity.
So can the center of buoyancy be above the
No, cannot. कैसे above होगा, above हो ही नहीं सकता। ठीक है, it has to be either, ये maximum वाला केस ये है, it will coincide with center of gravity when the body is fully submerged, and when the body is partly submerged, the center of buoyancy is below, क्योंकि center of buoyancy होता क्या है, जितना वॉल्यूम बिलो लिक्विड है उसका सेंटर ऑफ ग्रेविटी, जो वॉल्यूम अंदर है तो उसका डायगोनल इंटरसेक्ट करो, ऑब्वियसली वो नीचे आ जाएगा। समझ आ गई बात। तो सिग्निफिकेंस क्या है, सेंटर ऑफ ग्रेविटी पे क्या लगता है, वेट, थ्रस्ट लगता है बॉडी का। ठीक है, और सेंटर ऑफ बॉयंसी पे क्या लगता है, अप थ्रस्ट। क्या रिलेशन है दोनों में, सेंटर ऑफ बॉयंसी इज बिलो सेंटर ऑफ ग्रेविटी फॉर अ body which is partly submerged, and it coincides in case when the bodies are fully submerged. इतना समझ आ गया, ठीक। Let's now look at what is Archimedes principle. So let's understand what is Archimedes principle. Archimedes principle gives us the magnitude of buoyant force. अभी हमको मैग्नीट्यूड ऑफ पॉइंट फोर्स कौन देता है, आर्किमिडीज प्रिंसिपल। तो उसका स्टेटमेंट है, व्हाट इज द स्टेटमेंट, it states that the buoyant force acting on the body is equal to the weight of rate of fluid displaced by the submerged part of the body. So what is the buoyant force? It is equal to the rate of fluid displaced by the submerged portion of the body. ठीक है? यानी इस केस में how much volume of liquid it has displaced? Equal to the volume of body itself. तो यहाँ पे क्या है? इस केस में V liquid is equal to volume of the body. फुल वॉल्यूम ऑफ द बॉडी के बराबर लिक्विड हटाया उसने, मतलब जब ये बॉडी नहीं था उसमें, उस वक्त वहां पे लिक्विड था, अब उसने अपने वॉल्यूम के बराबर का लिक्विड डिस्प्लेस किया और वहां पे आया. इस केस में क्या है?
Volume liquid is more
लेस
than volume.
लेस देन द टोटल वॉल्यूम ऑफ द बॉडी. समझ आ गई? समझ आया? Yes. So this is, now read this statement again. It states that the buoyant force acting on the body is equal to the weight of fluid displaced by the submerged portion of the body. ठीक है? तो अब देखो, निकालते हैं इसको. That is अभी let us find out how much buoyant force is acting. देखो, अभी समझो हमारे पास एक ऑब्जेक्ट यहाँ पे है. Suppose some object is suspended inside the liquid which is filled in a container. ठीक है? तो ये यहाँ पे समझो कितना प्रेशर है? P1. और यहाँ पे कितना प्रेशर होगा? P2. ये दो लेवल. ठीक है? Now this is depth H1 और ये कितना डेप्थ है? H2. Depth is H1 and H2. कौन सा प्रेशर ज्यादा होगा? P1 या P2? P2 ज्यादा होगा. तो P2 is greater than P1. तो फोर्थ कौन सा ज्यादा होगा? P2 कितना हो जाएगा? P2 is equal to लेट. तो यहाँ पे थ्रस्ट ज्यादा होगा कि यहाँ पे थ्रस्ट ज्यादा होगा?
P2 पे ज्यादा सर.
ठीक है?
F2 would be more. F2 would be more.
F2 will be more. So F1 कितना होगा?
F1 will be less than F2.
P1 A होगा, है ना? एरिया तो सेम ही होगा, ऊपर का एरिया और नीचे का एरिया सेम होगा. और F2 कितना होगा? P2. तो F2 बड़ा होगा. Therefore F2 is greater than F1. तो नेट फोर्स क्या होगा? अपवर्ड, वही अपथ्रस्ट है, therefore net force is equal to, ठीक है, यही नेट अपवर्ड फोर्स है जिसको हम बोलते हैं बॉयंट फोर्स। तो खाली नेट फोर्स अपवर्ड ही क्यों लगता है, साइड साइड में क्यों नहीं लग रहा है?
फोर्स अपवर्ड डायरेक्शन में
साइड साइड में भी लगेगा, प्रेशर तो हर डायरेक्शन में लग रहा है, सेम लेवल पे सेम प्रेशर है तो दोनों साइड से सेम फोर्स लगेगा, तो नेट फोर्स जीरो होगा इस केस में। भले वो फोर्स नीचे जाते जाते बढ़ते जा रहे हैं लेकिन हर लेवल पे सेम ही है, समझ आया? प्रेशर इक्वल बढ़ रहा है सेम लेवल पे, इसलिए बोथ साइड साइडवेज प्रेशर साइडवेज फोर्सेस कैंसिल ईच अदर, ठीक है। सो ये हो गया, तो कितना आएगा? दैट इज एफ पी इज इक्वल टू क्या हो गया, F2 माइनस F1, तो F2 कितना था हमारा, P2A माइनस P1A, ठीक है। तो ये क्या हो गया, ये कॉमन ले लो, P2 माइनस P1, P2 कितना हो गया, H2 रो जी माइनस H1 रो जी, रो किसका है, लिक्विड का, तो ये क्या हो गया, A H2 माइनस H1, ये हो गया रो जी, A इंटू H हो गया, तो H क्या हो गया तुम्हारा, इसका हाइट हो गया, H क्या हो गया, हाइट, H2 माइनस H1 इज H, but what is A into H, volume, this is the volume of the object, it is also volume of the liquid, ठीक है। तो मैं यहाँ पे लिख देता हूँ, since what is VL, VL is volume of the liquid displayed, ये क्या हो जाएगा, ML, what is ML, ML is mass of the liquid, volume of the liquid into density of the liquid, है ना, समझ आया कि नहीं? So what is VL, where वही तुम्हारा आर्किमिडीज प्रिंसिपल है, rate of the fluid displaced, where अलग अलग लिक्विड, वॉल्यूम ऑफ लिक्विड है इस केस में फ्लूइड displaced by the object of volume P, hence that is here is equal to here, ठीक है। और ml क्या है, VL into density, mass is volume into density, volume into density तो mass होता है, is mass of liquid. अरे fluid displaced. तो प्रूव हो गया ना हमारा आर्किमिडीज प्रिंसिपल वेरीफाई हो गया. ये जो अपथ्रस्ट है किसके बराबर है? इट इज इक्वल टू मास ऑफ और वेट ऑफ फ्लूइड डिस्प्लेस्ड. therefore mlg is equal to weight of fluid displaced. Thus Fp is equal to weight of fluid. यही तुम्हारा आर्किमिडीज प्रिंसिपल है. क्या है ये? Which is Archimedes principle. ठीक है. रेट ऑफ फ्लूइड डिस्प्लेस वही आर्किमिडीज प्रिंसिपल.